Okay, we have another one we're going to graph by using transformations. So we're still using the same base graph 2 to the x because there is a 2 here, so we're still using this one. What's happening on this one is, let's take a look at the transformations going on here first. First we got a plus 2. So plus 2 means that the graph is going to be shifting up 2 units. So in fact what we can do is we can get the horizontal asymptote. We start with y equals, and it's always going to be the number that comes after the exponential part, the one that does not have an exponent on it. That number is going to be what we put here. That's your horizontal asymptote, the y equals 2. So we know that it's going to move up 2 and we'll have that horizontal asymptote. I have a negative on the outside. The negative on the outside does this kind of flip. It's going to flip it over the horizontal axis. So I'm going to draw in this dotted line. That dotted line right there will represent what happens when I flip the graph upside down. So that'll take care of the negative. Now I also have this on top. I have an x minus 1. What the x minus 1 does is it'll move the graph one place over to the right. So what it does is it'll move the graph up 2 units, it'll flip it over like this, then it moves it one place over to the right. My intercepts are going to tell me how that is actually going to be graphed. So I'll find the intercepts first, I'll plot those, and we know the graph's going to have to resemble this particular shape right here. So let's find the x-intercept. For x-intercept, the rule is you're always going to set that the y equal to 0. So 0 equals negative 2, x minus 1, plus 2. I want to isolate the part that has the exponent in it. So I'm going to move this part, since it's negative, I'll move it across the equal sign. It's going to become positive. So I have 2 to the x minus 1 is going to equal 2 that would be 2 to the first power there. Bases are equal. We'll set the exponents equal because of the equal basis property. Add 1 to both sides. We get x is equal to 2. So 2 is going to be our x-intercept. Next, I want to find the y-intercept. Y-intercept is where you put in a 0 for the x. So for this we have negative 2, I have 0 minus 1, and then I have plus 2. So when I do this, I get y equals negative 2 to the negative 1 plus 2. Let's talk about this one right here, negative 2 to the negative 1. These negative signs do not cancel. What this really means is that if I have negative 2 to negative 1, that means that I have negative 1 and then times 1/2, because I can take the 2 that's here, negative, and if I move it down below, it becomes positive. So technically this part right here is equal to negative 1/2. So this, what I have down here, is actually equal to negative 1/2 plus 2. That's what I have for that part. That's equal to 3/2 if I combine that together with common denominators. So my y-intercept is going to be 3/2, or also it would be the same thing as in 1.5. Now I'll go ahead and put all this information on the graph that I'll do here. I know that the horizontal asymptote is going to be 2. So I'll put a dotted line going through 2 right there. My x-intercept is 2. My y-intercept is 1.5, or 3/2. It's going to be right there. We already know the graph's going to have to be drawn like this. It's going to have to go down. So I'm going to recreate that here. It's going to go through here. It's going to hit these 2 points. It's going to go down just like that. And that right there would be my completed graph. It is flipped down because of that right there. It has the 2 intercepts that are there. And if you notice that this graph is actually shifted over 1 to the right from where it originally was here. So we flipped it over, moved it up 2, moved it over 1 to the right, and this was our final graph.